Hi people. So this video is going to be about explaining or learning exploratory data analysis. Okay, so just before we go ahead, let's understand what is exploratory data analysis, what are its objectives, and I mean, why is it required, and what are the steps involved in doing the EDA, which is exploratory data analysis. Now, before I go ahead, let me inform you that this exploratory data analysis step or the method is actually used by data analysts or data scientists to find out the insights of the data. Okay, so the EDA is basically, or you can say it's a data exploration technique to understand the various aspects of the data. Okay, understanding data is very important for an analyst or a data scientist because without understanding, we cannot reach to any conclusions or we cannot find any story behind the data or the insights. So we need to make sure that the data is clean. So when you actually get the raw data, or if you can get a raw data from somewhere to do your analysis, the raw data may contain a lot of noises, and this noise can be in the form of missing data or unnecessary data or data which is absolutely not related to what we are actually trying to conclude. So you need to clean the data. And so basically cleaning means to remove all the redundancies and missing values and the null values. And in this way we can identify the most important features in our data set. Um, Now, removing all unnecessary noise in the data, which may actually, hinder the accuracy of the conclusion, which we actually will be using further for the model building. So it is quite important to do so. Right. So what is the objective of the EDA over here? The objective is to have a clean set of data, which can actually, in which we can actually see the insights quite bright, the actual story that is coming out of the data. Based on the insights, we can take decisions um, on what type of model can be used further, and with what type of model, what type of changes or strategies can be built to to take further action. So the data can be anything. It can be related to medical profession or sales data. So by doing the analysis, one can actually come to a conclusion on why things are happening and how it can be changed. Okay, or you can actually predict something which it cannot be easily seen. So there are a lot of things that can be done by data analysis, and exploratory data analysis is one of the most important step uh, towards in order to further go ahead with the analysis. Okay, so what are the steps involved in EDA, which is exploratory data analysis? So in order to check what are the steps involved, I have picked, in order to show you all, I have picked a data which is the very famous data set of Titanic. And this Titanic data set will be using the training part of the data set. And I just built a framework on how we are going to actually explore it. So I will take you stepwise, and yeah, you'll be able to understand what are the steps involved in doing the EDA. So just before we go ahead, okay, in this data set, there are almost 11 features. Okay, so for those who don't understand what are the features, so when we talk about the data set, it usually comes into the frame of a data frame, which is just like the Excel sheet you might have seen. There are columns and there are rows. Okay, so when we talk about data analysis, these columns are referred to as features. Okay, or sometimes as dimensions. Okay, so these are the features. So these are the columns in the data. Uh, Survivals. PC class is the passenger class. Name would be the name of the passenger, their sex, age, siblings, and spouses. So each passenger if they had their siblings along with them or their spouses. This PARCH parse is the parent child. Okay, the number of parent child contribution, or you can say the combination. Ticket numbers, fare of the ticket, okay, and then the cabin numbers, and the embark of the port from where they boarded the ship. So there were three embark ports, I believe. It's mentioned here. I mentioned it's Cherbourg, then Queenstown, Southampton. Okay, so just before we go ahead towards the step, okay, yes, there are a few things that we need to do. Okay, so there are a few packages that I will install because I'm using the Google Colab um, in order to do to further explore this data, and the Colab does not have few packages that I'm going to require. So what I'm going to do is I will install the package, and why I'm installing this package you'll soon come to know. Okay, uh, as we move further. So I'm going to do a quiet installation of Pandas profile. Pandas profiling, and this one is going to be 2.5.0. Okay. All right. So with this, we can actually get a complete report of the data that we are actually looking into. So what I've done is you can actually get this training data of Titanic from Kaggle. What I've done is I have downloaded the data to my system or to my Google Drive, and I'm going to uh, take the data from the Google Drive directly, and there are two set of data, which is train and test. So just to do the EDA, I'm going to pick up the train data to show you all how it works. So now since I've installed the Pandas profiling library, okay, I need to restart the runtime, okay, or else it won't work without it. Okay, so let's move further over here. I'm going to need few libraries over here. So the very first one that I will require is the pandas, which is import pandas as PD. You can do it as PD. Then I'll import warnings. So I usually do this because it helps, you know, uh, it helps in taking care of all the warnings that is displayed, just in case. What was it? Warnings, filter warnings. Okay, yeah, and then I'll do ignore. Okay, so what is the next library that we are going to require here? Um, let's take NumPy as NP. Okay, and okay, the one that we just installed, import Pandas profiling. Okay, so we will require a few uh, visual libraries as well to do our data visualization. So let's pick a few of them and let's see which one we will use it. So let's say Seaborn. Seaborn as SNS, and let's pick up Matplot. Matplotlib dot pyplot as PLT. So we have Seaborn and Matplot, and we will do inline. So this is so that the Matplot visuals are shown inside the boxes itself. Over here, Matplot lib inline. Okay, so what else? To display the Pandas profiling or the report that we will be creating, we will require from IPython. From Python, we will move to the display part of the library. And from there, we will import HTML and display so that we have, let's say if we might require iframe. All right, that sounds good. Let's move further and let's go ahead and load the data. Okay, there's some warning here. Maybe I typed something wrong. Okay, warnings.filter, warnings, missed out S over here. And a spelling mistake. All right, so this sounds good. So let's go ahead and further, we will go ahead and load the data. So in order to load the data, we can simply use a variable called train, because we are going to use the train data. And then we can do pd dot read underscore csv, and we can take the path over here. So I have kept the file inside my Google Drive. I've connected the Google Drive over here. If you see this, just clicked on it and you can connect it. And let's go to the drive. It's here, Kaggle competition, and here tightening data and the train CSV file. I'll copy the path and paste it here. And let's try to run it. Okay, so now we have the data stored in the variable called train. So let's check how does the data look. So there are two ways to check the data. Either you can use the head function, and it would simply display the first 5 lines of the data. So if you can see, we have an index over here, and then passenger ID, survived, passenger class, name of the passengers, their gender, um, age. Age shows up in the float, and then siblings and spouse, parent, child, ticket number, fare, cabin number, embarked. And if you can see this NAN, this is the missing data. Okay, so there will be a lot of, let's find that out. So right now, we did not require this index, and the passenger ID also is the same as index itself. So let's replace that. And in order to replace that, what I'm going to do is I will use index column. Okay, and let's make passenger ID the index. So I'm going to simply copy this and paste it over here. So let's check the data now. All right, that sounds good. So now we have the passenger ID as the index, and the rest of it is the feature. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11 features. Now, if you can see in this data, um, the dependent data, the feature is the survival. Uh, if you're going to actually work on the Titanic data, then you would be probably wanting to know how many people survived, because I'm just taking the train data. Train data has a survive this column here, or the feature. In the test, this data or this feature will be missing. In the test data, rest all will be there, but the survived data will be missing, and that's what you need to predict. But for now, since we are just doing the EDA part, we are not going to touch the test data. Okay, and let's go move further. Let's learn more about the data now here. The next step, what we will be looking into is what are the data types and the other information. So there is a function called .info. So we just need to take our data set, and you can do .info with the parenthesis and run this. So with this, you'll be able to see that we have all the 11 features here, and the number of non-null rows, okay, which is 891, and their data types. So survived data is an integer, class data is an integer, the objects are the string data, name, sex, age was in float, as I mentioned earlier. And if you can see, this also provides you with the information that in the age there are certain missing data, as well as in the cabin feature or data or the data. There are some data set. There are some values which are missing, and also in embark, very few number of missing data, but there is some missing. So in this way, by just doing the info, you learn a lot about the data. Uh, by just one single line of, not even line, just 2 words of coding. Next, what we will try to find out is, now though that we know that there are some data which is missing, but how much? In order to know how much data is missing, you can do this train dot is null. Okay. So by doing this train dot is null, you will be able to see the entire data. Now, this is one of the you can say the loopholes of um, Jupyter notebooks, or wherever you try to access them or use them. You won't be able to see the entire data. It hides lots of data. It will just display the first five and the last five. Okay, so in this way, if your data is quite small, you can directly go ahead and count this. But since if the data is very large, in lakhs or in thousands, you can just do the sum up of that. And by doing the sum, you will get what you're looking for, is the number of missing data. So age has 177 missing data. The total number of data is 891. Okay, and out of that, 177 is missing. So that means it is in the you can thumb rule, or you can say lower portion of the decision making, where people usually decide whether to drop the column, drop the feature, or to fill the data which is missing. So how do we decide that? So if generally whichever for column is missing the data, if the missing data is less than 25% or 20%, and if it can be replaced by some means, and by replacing, if it does not impact the entire uh, conclusion or the accuracy, then we go ahead and replace it. But it depends on situation to situation and data to data. And in many situations, we drop the features if the replaced data doesn't make sense. So but over here, we can actually replace it by a median or a mean of the entire data. And then the cabin numbers. Now look at, the cabin numbers are going to be different for each one. By assuming a cabin number for a particular passenger, it won't make sense. Moreover, this number of missing values, if you can see, out of 891, is 687 data is missing. So doesn't make sense in replacing the data with the fake one, because that's going to hamper the accuracy at the end. So we will be dropping this column. Embarked has only 2 missing data, so we can just use a mode of the values, whichever is the maximum, we can replace it by that. All right, so let's move further now. So we have a little bit of understanding of how the data is, and from now here we have checked the missing values and we have some observation. Now we can also check here what are the the columns. Um, I mean there are 11 columns or 11 features here, and there is a function called describe if you want to check the summary. So in this function, let's type that first, describe. Okay, describe. So this is going to take all the numerical data, okay, which is float and integer, and it will give a clear descriptive analysis of the features which are in numbers. So if you can see over here, the count of survived or the age or sibling, these are the counts, these are the mean of the entire value of the features, standard deviation, minimum, okay, which is the minimum value, and the maximum value. So siblings are like maximum 8, a parent child, they are maximum 6, okay, not more than that. And then if you can see fare, maximum fare was 512, minimum fare is 0. Okay, so there could be a possibility that there were special arrangements made for special people, but they're not charged. Okay, and if you can see the quartiles, 25 or the first quartile, or the median 50%, 75% quartile, you can look at in that way, in that angle as well. So you get a lot of information, descriptive information about the data which is in numbers. We can obviously do some kind of label encoding or one hot encoding to change the data which is gender to numerical data. Okay, uh, but that's something which will be handled in the next stage of EDA, which is feature engineering. So let's go further and explore more of the data. And here we are. Let's check the cardinality of the data set. So in order to check the cardinality of the data set, all that we can do is very simple. One line of code is train, and then n unique uh, unique number of unique items or number of unique values each data set has. Now survived has only ones and zeros. Zeros are the ones which are did not survive, and one which means the person survived. There are three classes: first class, second class, and the third class. Now if you can see, name all 891 names are different. So this feature is not going to be helpful for us for any analysis. So we need to drop this. Then 6 has, which is gender, which is male and female. So, there's only 2, 0 and 1. Age, and then ticket. Ticket has high cardinality. So name and ticket, these are the two things. And cabin is the one that we can, since it has a lot of missing numbers, these are the three columns that we can easily drop it. Okay, so in order to check the cardinalities or the features, I'm sorry, the items in the features or the categories in the features, I would say, to be precise, what we can do is we can actually take each one, like say, for example, the data and the any one of them. I'll pick, let's say, class, and then you can do unique. So that was n unique, number of uniques, and this one is just unique. And you can see these are the three values in the entire column. So if you want to check each one, you'll have to type each one. But what we are going to do here is we are going to simply, use some Python programming, okay, and try to find only those which has say zeros in their values, because zeros can be a null value as well as a valuable a valid value. So let's check what we can find with our a little bit of programming. So what I'm going to do is I'm going to use a for loop. Before that, I'm going to actually get the names of the column. Okay, let's say, okay, I already have the names up here. So I'll create a variable called features, in which um, the categories are less. I mean, like these ones survived. Let's say B class. So just copy and paste it. Okay, it has a lot of space here. So P class would be the one, and then age and sex, and then um, fair, and sibling, spouse, and parent, child, and the last one would be embarked. Okay, so I've handpicked the features because I don't want to pick the others which has a lot of cardinality, like the age. So obviously there can't be a child with zero age. Okay, it will start from one. So what I'm trying to check, all the rest which has any value which is zero. Okay, to understand if these zeros are valid values or not valid. So I'm simply going to use a for loop or x in features. Feature, there's no s. All right, let's put an s because these are features. Features, and I hope this is getting recorded. Okay, so yeah, let's come back. For x in features, we will create a list. Let's say list one, which has so I'm going to take train x, which is the feature, and unique of that. So I'm going to save the unique of each feature in the list one, and then if any in the list, if any in the list, any value in the list basically which is equal to zero, then I'll print x, and let's say I'm going to put some hyphen between, and then that is the name of the feature, and the the array which will show all the values which is there in the x, so the list itself. So in this way we will be able to see, say the fair has a zero in it. Okay, and then siblings has a zero. So I think siblings which has zero siblings is quite valid uh, value, because yes, the passenger can have zero siblings, and there could be a child with or a parent without a child. Okay, so there are parents without child, with one child, two, three, four, five, and six. So these are the values. Now, whatever we just found till here, okay, this is one of the way to actually explore the data. The other way that I prefer is by using Pandas profiling. Now, why do people use Pandas profiling? Is I mean, even this one has its own, you can say, positive and the negative side. Pandas profiling can be used where it quickly actually gives the insights of the data in the form of a report. However, if the data is quite large, you'll have to ignore the correlation part of the data so that it runs. So I'll show you how. So for now, what I'm going to do is I'll create a variable, and inside that I'll put the pandas profiling. Here it is. And in pandas profiling, there is a profile report function. And in this function, I'm going to put train, and I'm going to use, so whenever the data is large, you can use this as true, minimal as true, so that it, uh, you know, the the maximum place required, the maximum number of data that is required for the processing in your RAM is for the correlation. So when you do minimum true, that means minimal true, that means you're avoiding the correlation part in it. So I'm going to show you both actually. Let's just do false first, and then after this, we are going to save this report in the form of an HTML document. So to underscore file, and I'm going to name this train.html, and let's put this under quotes. Okay, so I'm going to run this. Okay, so our report building is done, and now I'm going to display the report to see what it shows. So in display function, okay, so this display is something that we actually imported in the beginning from the IPython display. I've imported HTML display and iframework, so I'm going to use the display part of it. I think that should be fine for now. And in the display, what we want to display is, if you can see, we have a new file here now called train HTML. So you just need to open the HTML file, and what I'm going to do is I'm going to use HTML, and within HTML I will be using the function open, and inside open I will use the path, copy the path and paste it here within the quotes. Okay, so this one is done, and in the HTML part you can do a dot read so that it reads. So we have display HTML, and inside HTML open function, and you need to open this path and read it. Okay, so all set, and run this. Okay, so we have the report here, and I'll show you how it looks and what is the difference in minimal, true and false. So over here, I'll show you what is the benefit of this report. So once you get this report from Pandas Profiling, you directly get this third column. If you see third tab, it says warning 8. So it says name has high cardinality, which we saw earlier. Ticket has high cardinality, and the cabin has high cardinality. Age has 177, which is 19.9% missing. Cabin has 77% missing. Siblings and spouse has 68% zeros, which is a valid value. We found that. Sometimes the data has zeros, which is invalid. The parent child has 76% and missing values, zeros, sorry. And the fare has 1.7% as zero values. So this is a useful information. I'll just show you a few over here because the time for this video is increasing, I believe. So this is the sibling part. Okay, so if you just click on the toggle details, you'll be able to see this descriptive analysis just we saw, but this one is for the single feature. In this, you will be able to see the kurtosis is quite high, which is required to be normalized, and the skewness is quite a little bit okay. The histogram over here will show you the number of uh, passengers who have 0 siblings is more, and then 1, and then 2. Okay, there is 1 8, so this can be referred to as outlier. And then the third one, which shows most common values, which is 0. Most of the passengers does not have siblings on the ship, and the number or count of them is 608. And also the extreme values. So the extreme value has minimum 5 values, which is from 0 to 4, and then maximum 5 values, which is from 8 to 2. Okay, so right, so we can see the minimum values as I mentioned, and the maximum values which are in the feature. So in this way, you will be able to see the insights of each and every feature, and then in order to use these data in a model, you will be you will actually try to normalize the data first, do the feature engineering, find out the most important features which actually put a lot of effect on the label or the final, the value label would be the survive, whether the passenger survived or not. So to your answer basically, so you need to find that out. So these insights help a lot. In this report, you can see a correlation data. Even though this correlation data doesn't give much information, because these, apart from the colors in the correlation data, to understand there isn't much. So we can actually make a much better correlation data without the report. So what happens is, if the data is quite large, then the report doesn't get, the report gets created, but you cannot display it with your libraries in the Jupyter notebook. So that becomes a little challenging. So what we usually do is, since we do not need this correlation part, we use minimal as true. And when we do that, then the report gets created without the correlation part, and it's very quick. Okay, so you see how quickly it got created compared to the last time. So this data doesn't have the correlation part. It just has the insights of the feature. Okay, so let's proceed further, and we are going to drop a couple of data, which is the 3 features which we spoke about, which is a name, ticket, and cabin. So what I'm going to do is I'll do delete train and name, and in the same way I will so we have delete train name, and then train ticket. Ticket was spelled as T capital, I believe, yeah. And name also had N capital. And the last one was cabin. So if I'm not wrong, I hope the names are correct. Yes, name, ticket, and cabin. So we'll drop that, and moving further. Oh, I think yeah, I see. Okay, spelled wrong. Okay, so since I ran this 3 times now, the name is already deleted, so it gives me an error. So I'm going to comment that out, and now I can remove the comment, and all 3 data sets is gone. So in order to check if it's what are the remaining set of the features? You can just simply use train dot head. Okay, and these are the remaining set of the data or the features of the data that is removed. So let's talk about a little bit on the outliers. So we just saw that there's an outlier in the fare part, where the price of the fare, most of the fare was around $20-$30, but there was one around 200 or 250. So how do we find that out? So in order to find that out, what we will do is we are going to say you know, plot a little, say a histogram. So a histogram will actually help to um, display how's the distribution of the fare. So what I'm going to do is I'm just simply going to take this fare feature and use a histogram. So with this I'll be able to see. So if you can see, so we have the ticket price is starting from 0 to 100. Most of them are between 100, and then very few like less than 50, between 100 to 200, 10, 20 maybe between 200, 300, and there's only one or two at the price of 500. So this can be considered as outliers, and we can remove these outliers to make our data quite normalized. So what we will do over here is we will remove this. And how do we remove this? We are going to simply the entire data filter the entire data, and by using uh, let's say, okay, train fare, where we want the training data where the train fare is less than, say, 400. Yeah, I think 400 would be the best. 400 would be better marking. So after doing this, let's create another cell. If we check this again, and now the outliers are gone. Okay, this still sounds like an outlier, but then we can keep it for now. Okay, and let's start working on the missing values. So the next, in order to take care of the data, since there were a lot of missing values, how do we take care of the missing values? Is, let's say, so the missing values were, okay, we just saw that in the beginning over here. So, and here as well. So we had missing value in the age, cabin, and embark. These are the three features: name, age, cabin, and embark. So I'm just going to plot that over here once again. So we have it in front, or displayed here. So is null, and then sum, and here we have that. And so age, embark, cabin is already gone. So we have only two. So we need to take care of the missing values in age and embark. How do we do that? We can just simply use the function called fill na, and that should take care of it. So what are we going to fill it with? That part is quite important. So for that, it totally depends on the type of the data that we are looking at. So age can be filled with median, and your embark can be filled with a mode. Okay, so I hope you all know what is median and mode. So what I'm going to do is I'm going to use train age. I'm going to take this feature and then do a dot fill na, and I need to fill the na with train age, which is the same features median. Okay, so this is how we will fill the missing age, and I'm filling it with the age value in this column, the median of the value in this column. And also I'm going to do in place, so that it doesn't create a new form of data. In place true. Okay, so it's going to replace it's in its own place. And also the same thing, I can do it for join, and you can use embarked. So embarked has missing values. Fill NA train embarked, and from this we're going to take the mode to fill this. And the same thing, the mode that we will take is the first one, because it will be a list. Okay, so it's the first one, and that is 0th index, and then in place it's equal to true. So with this we have filled the missing values. In order to check how if there is any other missing value, you just simply take this and rerun it on a new cell to check if there is any other missing. So if you can see, all the missing values are filled now. So we can do a little bit of data visualization as well to in order to check what is the relation between these datas for a clear insight, and that would be a better option. So let's start with distribution of survivors and non-survivors. So let's take what visualization we can use. Matplotlib directly. Let's say plt dot figure. Let's take a figure size size of say by 8 by 6, and train. We'll take the entire data uh, and the survivor part of the entire data. So survived, because we are trying to check the distribution of the survived people. And then we're going to do a value count. Okay, value count, and then we can normalize it over here, because we are going to display. So this is the quick technique to normalize a particular feature um, while you're displaying. Normalize equal to true, and then with this data, okay, so we have taken the survived value counts and we have normalized it, and we are going to plot let's say a bar chart. So the kind will be bar, and let's put some color. Color will be, there will be two bars coming in, so we can take a yellow and a red. Okay, so yeah, that sounds good. I think, yeah, it's it. And let's make a little create a title or a label. X label would be for, let's say, 0 is non-survivors, and 1 is survived people. Okay, so in this way you can actually create your plot and label it and title it and all. Um, so just to make it a little quick, I'm going to copy paste here, and then in order to show the plot, we do plt matplotlib show. Okay, so there's some error. Okay, this is supposed to be a comma. So we have okay, there's still some error. Okay, spelled it wrong again. All right, so we have zeros, which shows that the maximum number of passengers did not survive, and compared to the passengers who survived. Okay, let's do a little bit of distribution of survivors based on the class, passenger class, and their sex, which is gender. And let's take plot tlt dot figure, and let's take the figure size a little bigger this time, because it's going to have at least 3 class. So I'm going to take 12 by 6, and we can take subtitle distribution of survivors based on, okay, you can mention something like that. I'm going to copy this itself. Okay, and then over here we can actually use your Seaborn Boylan plot, and inside this I will put the data as train, and your X as let's say P class, and your Y as survived. Survive, is it here? Survive. And you can use what else we can use here? U. U can be 6, and you want it to be split. And lastly, you can, the cut has to be 3. Okay, so that sounds good, and I will do show plt.show. In this, you will be able to see the passenger class 1, 2, and 3. The blue ones are male, and the other color is red or brown, is female. Okay, now these are the ones which have survived. Okay, and yeah, not survived and survived. So basically, if you can see the um, observation here, we can see more number of men survived in you can say men survived in class 1 compared to the other class. Okay, so 0 is actually not survived, 1 has survived. So more number of men survived in the first class, and women's from first and second class were given first preference to survive, so to their survival, and compared to the women in the last third class. Okay, so however, the graph shows only about the survivors. Okay, so finally we'll do a correlation to see, since we did not get to see the correlation in the report that we created. So there are many other ways to do the visualization to see the relation between the attributes amongst themselves, and which one makes more effect on finding the whether the person survived or not. Um, that there are a lot of things that we can do in this, but for now I'm going to end it with the correlation. And in order to find out the correlation of the data, we can actually change the data, all those data which is in the object format or the string format. We can do as I mentioned, we can do label encoding, one hot encoding and change them into numerical data, and then we can do a correlation. But for now, I'm just going to uh, do the data which is already there as it is, since the recording has extended quite a bit. Okay, so here we go. If you find out the correlation, this is how it looks. So let's put this into a heat map. Okay, so in order to visualize it, what I'm going to do is I'm going to take a figure and then figure size as say 15 by 8, 15 by 8, and fns dot heat map. Inside this, we will put train.0rr, and we are going to endnote it. Endnote this will be true, so that it gives out the numbers inside that, so we can find out the relation, and then we can use a little colors by C map, and we can use. So there are a lot of combinations of colors you can find out on Google. C map colors, and you will be able to see a lot of combinations. Like this one is PIGY. Okay, so if I run this, you will be able to see. This is the correlation matrix. Now, if you can see, the number of survivors according to class is 0.33 minus, which is in minus, and then age. So how this feature is related to the finding of survived or not is in minus again. So the most important feature that we can see here is 0.8082, which is in positive, and these are two. However, this is not the exact, I would say, the right way of finding, because we are missing a couple of features which were not converted into label into the numeric uh, values from the string. So once you do that, you'll be actually able to see what all features are most important. That those are the features that we can use it for the model that we will be building in future. So that brings us to the end of the EDA part. This is how we try to understand the data. Okay, by these are the steps which are involved in understanding the data, analyzing it, and finding the insight. After this, the next step would be feature engineering. By feature engineering, you can find even more insights by doing some complex, programming, or a complex way to find out. So before you do the feature engineering, you should know what exactly needs to be done. Like label encoding or one-hot encoding also comes into feature engineering. That's why I haven't done this. And then after that, once you have the all the features ready, you have to normalize those features. That is called data normalization. Find out the most important features, leave the rest, and whatever model you build, you use those important features, and get the accuracy from that. And once you have the accuracy, you can do your model explanation. So that brings us to the end of this topic, which was EDA. I hope you all have uh, got a little bit of understanding on now on how the EDA works and why is it required. Thank you so much for your time, and have a great day.